Hello. Hello and welcome to this video. In this video, we will deal with the trait iterator. We have already seen several traits. The most notable, I think, the last two were the impulse trait and the drop trait. So what does iterator trait gives us? So you take any sequence and you want to make it iterable, then you make that uh, object implement the iterator trait. So what is required for an iterator trait is that it has to have a type item and then it should implement the next method. Okay. This next method takes a mutable reference of the object and returns the optional self item. Okay. So a lot of functions are provided by this iterator trait. So you can read about those in the standard library. We will implement these later on, but just for reference, you can remember this. So for example, we have a structure Fibonacci and it has two elements, current and next. Note that this example has come from Rust by example from the documentation. So the current and next are both of type unsigned integer 32-bit. Now, as we know, just we saw that we need to implement the iterator trait for Fibonacci to make it iterable. And we declare the type item U32. Now we implement the next function. The signature remains the same, which was given in the documentation. And the logic inside is that it's a Fibonacci sequence, so implement the Fibonacci number logic. We have current, which is equal to self.current. Then current becomes the next, or rather the next becomes the current, and next becomes current plus self.next. Now note that when the iterator is finished, none should be returned. But in this case, there is no end of Fibonacci sequence, so we don't implement or rather we don't return none. We simply return sum and current inside that. Current is wrapped by sum. Okay. Now to initialize this object, we have a Fibonacci function which returns a type of Fibonacci and we set current to 0 and next to 1. So that is our bootstrapping the Fibonacci object. Now in the main example as given in the book, we have a range 0 to 3. So this is the range 0 to 3 which we have named sequence, mutable sequence. It has to be mutable because the function will mutate this. So it is of type range i32 and we make 4 calls. So first 3 calls will print 0, 1 and 2 and then it will print none. Okay, because 3 is outside, it is half open, half closed. It is closed on the lower side, that is 0 is included, and open on the higher side, that is 3 is excluded. So it will print 0, 1 and 2. Now the for loop we have already seen this earlier. For loop iterates over a range. So here it will print 0, 1, 2. Now what we can do is we can take n method. So it reduces iterator to first n terms. So here we take 4. So what it will print? It will print 0, 1, then 1 and 2. We can also skip a certain number of items. So here we are skipping 4. So we skip up to 4. Then it will print 3 and then 5 and then 8 and then 13. And then finally we have an array and we convert into iter by calling iter method on the array and we print the array. So the array will print 3, 3 and 7. So let's see this in action. Let me launch the okay, let me increase the font size. We go to Rust programming iter 1. Okay. So we say cargo run. Oops. Cargo run. So you say it prints some 0, 1, 2 and none for the initial range. Then it prints 0, 1 and 2. And then it prints the first four terms of Fibonacci series. 0, 1 and 2, 0, 1, 1 and 2, and the next four terms is 3, 5, 8 and 13, and the array is 1, 3, 3, 7. I missed this one when I was reading about the array. Alright, so this is how we iterate our Fibonacci. Now if you really want to look at what next is, in Visual Studio you can control click this. So it will come here, and that's how it actually calls spec next. You can go and see the implementation of spec next. So this is how you implement the spec next. And if you want to see force check implementation, you can go ahead and look at this. So similarly, if you want, you can look at take function. Now, if you look at the take function, it is part of the iterator.rs. Now, if you want to see what methods are provided by, then they do array chunks, byte ref, resize, chain, clone, copied, cycle, and so on. There is filter, which we are very interested in. There is filter map, flat map, fuse. We just use take. We just use skip. And then there is sum. There is step by, which we use in for loop. When we want to step by other than the typical one, then there is chip. When you want to merge two iterators into one iterator, then you got zip, then you got reverse and scan and so on. So a lot of functionality is provided by iterator, and it allows us to do kind of functional programming. So it is very important. Once I have finished the Rust by example, I will delve deeper into the functional programming style which we can do in Rust. So with this, we come to the end of iterator array, the initial implementation and description. We will revisit iterators when we implement more functionality. For example, right now only next is implemented for this, but as you have seen in this what you call range dot or rather iterator.rs, we can implement a lot more functionality. Okay, so suppose you want sum of say first four elements, or sum of four elements after skipping four elements, and so on. Okay, so we'll see all those implementation when we implement more and more iterators on certain types. For example, a simple thing could be counter. So we can implement a counter iterator which can take, which should typically increase by 1. So the counter could be 0, 1, 2, 3, 4, 5, 6. And we might say that the counter can count up to 100. So you can end the count at 100. So if you want to do that, what could be that? Suppose here you can put an element called counter, which could be of type what you call I32, and you can initialize that with 0. And in the next, what you can do is increase that by 1 and return it. And you can also check if the counter is 99, then you return none, because you want to limit the counter to 100. So that's how you can implement a counter iterator. And similarly, if you want a counter, you can implement, for example, sum for the counter. So it can sum up to any number, or from 0 to 99, it can give you the sum. So if you sum up to 99, the sum would be 99 into 100 by 2, that is 99 into 50. So that would be 4950, I believe. 450, 450, yeah, 4950. That would be the sum. So similarly, you can implement other iterators. Also, we will see that the standard library, which contains stuff like lists and maps and so on, all the data structures, how we can iterate those. So with this, I will end this video here. I thank you for watching the video. Stay tuned for the next one, and I'll see you in the next video. Enjoy.